In match problem 6, we're again asked to find the derivative of a given function. So we could apply that 4-step process, but since we already have one example of that being worked out, instead what I'm going to do is just tackle this problem head-on with the entire problem there from the start. There's no particular advantage to doing this one way or the other, but this way we'll have a demonstration of both methods for calculating derivatives using the definition. So we're starting with the limit as h approaches 0 of this difference quotient. That's going to be the limit as h approaches 0 of the square root of x plus h plus 4 minus the square root of x plus 4 all over h. When we talked about limits, we saw a problem that was similar to this one. So even though we have this radical notation that's making this problem look a little more complicated, whenever we have those radicals, we can always apply the same approach here. And that approach is to multiply by the conjugate. So we're going to multiply by the square root of x plus h plus 4. And then for this to be the conjugate, we just flip that sign connecting those two terms. So plus x plus 4, and then divide by that exact same amount, or that exact same value. So again, we'll use the FOIL method. We'll expand out the expression that we have in the numerator, which will give us x plus h plus 4 minus x plus 4 all over h times the square root of x plus h plus 4 plus the square root of x plus 4. So in the numerator, we could distribute this negative sign, so that'll become plus a negative x minus 4, which means 4 and negative 4 will cancel out. X and negative x will cancel out. And I actually forgot my limit notation here, so let me add that back in there because we're still evaluating that limit as h approaches 0. So this is going to be equal to the limit as h approaches 0. The only term left in the numerator now is h over h times the square root of x plus h plus 4 plus the square root of x plus 4. So h over h will cancel out, leaving us with the limit as h approaches 0 of 1 over the square root of x plus h plus 4 plus the square root of x plus 4. So now we have something that we can evaluate using direct substitution. We canceled out that lone h by itself in the denominator. We still have an h here, but if we plug in 0 for that, we won't end up with a 0 in the denominator. So direct substitution is going to give us 1 over the square root of x plus 4 plus the square root of x plus 4, which is just going to be 1 over 2 times the square root of x plus 4.